Hey, 7th grade. In this video, I want to talk about inequalities word problems. These word problems are going to be similar to those that you saw in the last unit over equations word problems. We're going to be writing let statements, inequalities, and then final answers in full sentences with labels on each of these. Very similar process to what we've already done. So let's go ahead and get started with number 1 here. So this one says the hard drive in your computer has a capacity of 120 gigabytes. That's just the unit of measure for something like space on a computer. You have used 85 gigabytes. You want to save some home videos to your hard drive, and so the question is asking what are the possible sizes of the home video collection you can save. Okay, so you'll hopefully remember from the last unit that our let statements, which is the first thing we write for a word problem, are just meant to assign a variable to whatever we're trying to find. So in this case, we're going to let x be equal to the possible sizes, or you could say gigabytes, of video. Okay, now let's look at what we're given. Let's look for a total first of all. We know that our computer has a total capacity, okay, of 120 gigabytes. Okay, so I'm going to put that by itself over here on the right side. I also know that I've used 85 gigabytes so far on the computer. Okay, so that's going to go over here on the left side. We want to know what we can add to this 85 here, okay, so that we don't take up too much of the hard drive space. Okay, so we want to know how much can we add to this 85 so that it doesn't go over 120. Okay, so we're adding X amount of space. Okay, X is the amount of video we're going to be adding. So I'm going to take the 85 we already have plus X, and that cannot be more than 120. So I'm going to say that 85 plus X has to be less than or equal to 120. Otherwise, we would have too much video on our hard drive. Okay, so 85 plus x is less than or equal to 120. Now to solve that for x, I just need to subtract 85 from both sides. And I get x is less than or equal to 35. Okay, so for your answer, you would say something along these lines. Okay, the videos cannot exceed. Okay, exceed means be more than, so the videos cannot be more than 35 gigabytes. So that's the process for setting up one of these problems. Again, let statement, inequality, we solve the inequality, and then we put our answer in a sentence. Let's look at number 2. For this problem, it says a club has a goal to sell at least 25 plants for a fundraiser. Club members sell 8 plants on Wednesday and 9 plants on Thursday, and the question's asking what are the possible numbers of plants the club can sell on Friday to meet their goal. So for our let statement for this one, we can say let x equal, we're talking about plants for this one, okay? What are the possible numbers of plants? So we can say number of plants. Okay, look for a total first of all. In this case, our total is a fundraising goal. So we know we have a goal to sell at least 25 plants. So I'm going to put that 25 on the right side here. We know we already have sold 8 plants on Wednesday. Okay, so that's something that we've already sold. So I'm going to put that on the left. I've also sold 9 plants on Thursday. So I'm going to add that 9 to the 8. Okay, so 8 plus 9 is what we already have. We're going to add to this 8 plus 9 our X value here. That's the number that we're going to sell on Friday. That's what we're trying to figure out. And we want to sell at least 25. Okay, so we want this 8 plus 9 plus X to be greater than or equal to 25. That's what at least means. We want the amounts we actually sell to be greater than or equal to 25. So that's my inequality for this problem. Now I'm going to go ahead and solve that. I can combine my 8 and my 9 to 17. So this gives me 17 plus x is greater than or equal to 25. And then I can just subtract 17 from both sides. And that gives me x is greater than or equal to 8. Okay, so that tells us that the club must sell at least 8 plants. it's important to use that phrase at least or at a minimum, okay, 8 plants, because that signifies that we can sell more than 8, and that's fine, but 8 is the bare minimum we need to sell. Okay, so make sure you're using the phrase at least or a minimum of 8 plants or 8 or more plants, something that shows that you can sell more than 8, but 8 is the smallest amount. Okay, moving on to number 3. We'll get a little bit more challenging here. For this one, it says you walk dogs in your neighborhood after school. You earn $4.50 per dog. How many dogs do you need to walk to earn at least $75? Okay, so look for the question first of all. This is asking us how many dogs do we need to walk. So let statement could be let x equal number of dogs. Okay, our goal, we want to earn at least $75. So 75 is going to be my total. We know we earn $4.50 per dog. Per always means multiply. So that means we're going to take 4.5 times our x. Okay, so 4.5x, and we want to make more, at least 75. Okay, so that means I'm going to use another greater than or equal to sign. I want the amount we earn over here on the left to be greater than or equal to 75. So now to solve this, I just need to divide both sides by 4.5. Okay. And when you do 75 divided by 4.5, you get a decimal of 16.67. Now, even though that's the answer we get for x, we need to think about that answer in the context of this problem. Okay, because look back at your let statement. X represents the number of dogs. You can't walk 16.67 dogs. Okay, that wouldn't be possible. Dogs we measured to the nearest whole dog. So we need to actually look at this inequality more carefully. If x has to be larger than 16.67, the next whole number larger than 16.67 would be 17. So for our answer, we need to say, you should walk at least 17 dogs. Okay, 16 is not going to do it. We need to walk at least 17 dogs. Okay, example 4. This one says a student club plans to buy food for a soup kitchen. A case of vegetables costs $10.68, and the club can spend at most $50 for this project. What are the possible numbers of cases the club can buy? So the let statement for this one, we can let x equal the number of cases. That's what we're trying to find for this problem. Okay, my goal is $50 for this one. So 50 is going to go over here on the right side. And we know that one case of vegetables costs $10.68. Okay, so that means that x cases would be 10.68 times x. Okay, 10.68 per case. So this is another problem where we have to multiply the price by the number of things, in this case the number of cases. Okay, in this case though, these students in the club are not selling cases, they're actually buying cases. Okay, they're buying the cases for the soup kitchen, and so you have to be careful with your inequality sign for this one. This one says the club can spend at most $50. So that means that this 10.68 times x has to be less than or equal to 50 because it has to be at most 50. You can't go over it. So we use a less than or equal to for this problem. Okay, now we're going to solve by dividing both sides by 10.68. We'll get another decimal answer for this one. 15 divided by 10.68 comes out to be about 4.68. So x is less than or equal to 4.68. Again, we need to think about our answer in the context of the problem. Okay, we're buying whole cases of vegetables here. Okay, so we can't do a decimal part of a case. Normally, if you see something like 4.68, you round that number up because you see after the decimal place you have a 0.6. Normally we would round that up to 5 is the rule. Anything 5 or above you round up. But you have to think about the problem in terms of an inequality. X has to be less than or equal to 4.68. If you round this number up to 5, 5 is greater than 4.68. So that's not going to work for our problem. Because of the less than or equal to sign here, we actually have to round down to the next whole number, which would be 4. So to answer this problem, we're going to say that the club can buy at most 4 cases. Okay, 4 cases, because if they go over 4, they're going to spend too much money. Okay, and the last problem, this is going to be a geometry problem. It says, in a community garden, you want to fence in a vegetable garden that is 12 feet long. You have at most 42 feet of fence to use. What are the possible widths of your garden? Okay, so for this one, our let statement is going to be let x equal the width. Okay, it's asking us what are the possible widths of our garden, so that's what our let statement is going to be, let x equal width. It's telling us the formula up here. It's saying P equals 2L plus 2W. That is the formula for perimeter of a rectangle. So it might help us for this problem, since it's a geometry problem, to draw a rectangle. Okay, so imagine this is your garden right here. Okay, we know a little bit about the garden already. We already know that the garden is 12 feet long. Okay, so we know the length of the garden here and here is 12 feet. The width of the garden is unknown. That's our x. So that's going to be this side and this side. And so now what we're going to do, we're going to take this formula that it gave us, P equals 2L plus 2W, and I'm going to convert this formula into my inequality. Okay, so here's that formula again. 2L plus 2W equals P, the perimeter. Because we have 42 feet of fence to use right here, we know that's going to be our perimeter. Okay, the amount of material we have is going to be make up all the edges of this rectangle here. So 42 is actually my perimeter for this one. So I'm going to make that P a 42. We have at most 42 feet of fence to use. So however much fence I use over here on the left side, it cannot exceed 42. So I need to make sure that the left side here is less than or equal to 42. It can't be more than 42, otherwise we run out of fence. Okay, I know the length of this garden is 12. So using this formula up here, I can substitute a 12 for my length. So that's going to be 2 times 12. The width, again, is my x value. So I'm going to say plus 2 times x. And now I have the inequality to solve. Okay, 2 times 12 plus 2 times x is less than or equal to 42. So 2 times 12 I know is 24. From there, I'll need to subtract 24 from both sides. So that gives me 2x is less than or equal to 18. And then finally, I'll need to divide both sides by 2 to figure out x. And I end up getting x is less than or equal to 9. So that tells us that the width of the garden must be less than or equal to 9 feet. Okay, so like I said at the beginning, these problems are very similar to those equation words problems that we did in the last unit. The only difference is you're using inequality symbols for these, and it's very important that you focus on getting the correct inequality symbol, okay, the correct sign facing the correct direction, and that you're using the extra phrasing in your sentences like less than or equal to, or at least, or at most, okay, phrases like that in your final answers. We'll practice this more in class the next time I see you. Until then, have a nice day. You're all wonderful people.